In this demonstration, we're going to be designing the engine cover for the Iron Eagle mowing machine. Edge ST3 has an integrated design environment that allows you to apply ordered features to synchronous models. Synchronous modeling provides a perfect foundation for accelerated design, faster edits, and handling imported data, and all the time allowing ordered features for process type parts. Synchronous modeling helps you model 3D parts quicker because design pre-planning is no longer needed. So as we begin to design this engine cover, we're just drawing and dragging sketches into 3D features. Sketches can be placed out in 3D space or directly on the model, such as we're doing in this case. When selected, the closed sketch region displays a handle, and a quick grab and go turns them into 3D features. Pulling regions adds geometry, pushing them in removes material. So with fewer commands to learn, new users adopt Solid Edge faster, and experienced users design more efficiently. Working top-down, which is what we're doing in this case, we're designing in the context of the assembly. We can use adjacent parts as a guide, ensuring that the parts are going to fit together. In this case, we're creating a parallel relationship between the back of the seat and the front of the engine cover. Fast, flexible edits make designing in Solid Edge a fluid experience. Geometry creation and manipulation is simple. Select a 2D region or a 3D element and use the drag handles to edit the part to shape. Dimensions appear and can be added at any time for precise changes. Next, I can see that we have some interference with a sheet metal part in the assembly. And this is the advantage of using top-down, is that we can see these types of interferences. I'm going to use the include with an offset to provide clearance around the sheet metal part by selecting its edges and offsetting them. These two edges form an open profile. In the extrude command, I need to tell Solid Edge that I want to chain my selection and that I want to remove material. While synchronous forms the design foundation, Solid Edge ST3 allows adding ordered features for process type steps such as castings with its machine counterpart or documenting the cutting steps after weld operation. Here we're going to add a stylized shape to the top of the engine cover using Solid Edge's rapid blue surfacing tools to increase the appeal of the final design. In order to create a blue surface, we need to first create a cross curve and a guide curve. To start the guide curve, I'm actually going to begin by using an arc. I'll connect the midpoint of the arc to the center plane of the part. And then I will convert that arc to a curve. In order to create a surface out of these two curves, they must be connected. Solid Edge has a unique way to connect these by using the blue dot. This will connect these curves regardless of the order in which they were created. The blue surfacing tool allows me to create the stylized surface from the two curves. Next, we want to replace the top face of the engine cover with the stylized surface. Adding treatment features such as rounds is very quick and easy. A final treatment feature that we need to add is a thin wall to actually make this part hollow so it will fit over top of the engine. Creating models with synchronous features and having the ability to add ordered steps greatly extends our capabilities. We have the speed and flexibility when making precise edits, and any ordered operations documenting a process are maintained. Here we're rotating the side faces of the engine cover, and live rules are keeping it symmetric. Notice as we change this angle that the treatment features are updating as well. We can also make precise edits using the dimensions. Notice how Live Rules maintains the symmetry of this part. Once again, we'll turn on the background component so we can see this engine cover in the context of the assembly. We'll add some more style by rotating this back face of the engine cover. Finally, we may wish to change the shape of the stylized surface. In this case, I can use the blue dot to make this edit. We're going to use a shape preserving edit, which tries to maintain the overall shape of the curves as we pull the blue dot. Notice that it doesn't matter the order in which the curves were created, that I can pull that surface however I want. I'm going to turn on the curvature comb so we can see our curvature. And I may wish to actually edit this in a local edit mode, which will only edit the curve in that particular area. We'll make one more local edit on the back side of the engine cover to pull this down to give it even more stylized shape. Finally, as I turn on the background components, I can see that the engine is actually poking through the side of the engine cover. So I need to cut away the material in this area. Once I have the part in the proper orientation, I just simply need to sketch a shape that I want to cut away for some clearance. Again, I can include geometry from the engine cover itself. And we'll add fillets to the corners. This again is an open profile, so I'll tell Solid Edge which way I want to remove material and in which direction. And now that I have that interference removed, that finalizes the design of the engine cover. With an integrated design environment, Solid Edge ST3 fulfills the vision of synchronous technology for accelerated design, faster, more flexible changes, and more reuse with imported data.